subscribe to my channel and press bell icon for latest updates.
Hi, welcome to Learning Monkey. I am Vikram. In this class, we'll try to understand gate bits, and these bits were asked in 2013 and 2014. So these bits were based upon logic gates and Boolean algebra, and the concepts that are related to these logic gates and Boolean algebra has already been covered in our previous videos. So we have taken nearly 25 to 30 videos to cover the entire concepts of logic gates and Boolean algebra. If you haven't watched those videos, please watch those videos and come back here, because the bits were discussed under the assumption that you have already watched that videos. So and every video in our channel is going to be a complete course, is going to be a part of complete course or a playlist. Our suggestion is to follow the complete playlist so that you can have better understanding of the concepts, and the link for the playlist is provided in the description below. Now coming to these bits, first bit, which one of the following expression does not represent exclusive NOR of x and y? So given these expressions, which of the following does not represent exclusive NOR? So what is the property of exclusive NOR? It is also called as exclusive NOR is also called as equality detector. So which means that if both the inputs are equal, then it is going to generate an output of 1. Okay, so if you take two input XOR gate, it is the outputs. So this is the XNOR gate, and these are the combinations of inputs, and this is a XNOR operation, and they are asking which of the expressions does not produce these outputs, for these inputs. That is very important to understand. So here this is the expression this is the direct Boolean algebraic expression for XNOR. So what does this mean? It is x comma y means it is 1 comma 1 plus 0 comma 0. So whenever the inputs are 1 comma 1 or 0 comma 0, then the output is going to be 1. So see here, 0 comma 0, it is going to generate an output of 1, 1 comma 1, it is going to generate an output of 1. So this is direct Boolean algebraic expression for XNOR. So this is not the right option. Now coming to this is XOR symbol. So X XOR Y bar. For example, if you take X XOR Y bar, this is the expression, and if you take 0 comma 0, and this is y complement, so it becomes 1. So it is 0 XOR 1. So the 0 complement becomes 1, and 0 XOR 1. 0 XOR 1 in XOR, it is going to produce an output of 1 whenever the inputs are different. Here the inputs are different. So it is going to produce an output of 1. Similarly, if you take 0 XOR 1, 0 XOR 1, so this is complement, 1 complement becomes 0, 0 0 is equal to 0 in XOR. And if you take 1 XOR 0, so this is 0 complement, it becomes 1. So it is going to be 1 XOR 1 is equal to 0. And similarly, if you take 1 XOR 1, 1 complement is equal to 0. So 1 XOR 0 is going to be 1. So this output is same as that of XNOR. This output is same as that of XNOR, 1 0 0 1. Okay, so this is also an XOR gate. Now coming to the third option, is X bar XOR Y. If you take 0, so same way we will try to solve this. If you take 0 complement, it is going to be 1. 1 XOR 0. 1 XOR 0. 1 XOR 0 is going to be 1. And if you take 0 XOR 1, 0 complement is going to be 1. 1 XOR 1. 1 XOR 1 is equal to 0. Similarly, if you take 1 XOR 1 XOR 0, it is going to be x complement is going to be 0. 0 XOR 0 is going to be 0. And if you take 1 XOR 1, this is going to be 0, 0 XOR 1 is going to be 1. So this is also same as that of XNOR. And our fourth option is, it is okay, it is X complement XOR Y complement, and if you take 0 0, it is going to be 1 1. So these are complements 1 1. 1 complement 1 XOR 1 is equal to, it is XOR, so it is going to generate an output of 0. And similarly, if you take 0 complement XOR 1 complement, so it is going to be 0 and it is going to be 1, it is going to produce an output of 1. And similarly, if you take 1 complement XOR 0 complement, 0 1, and the output is going to be 1. For example, if you take this 1 complement, it is 0 0. For 0 0, it is going to 0 XOR 0, it is going to be a 0. So this is not the output is not same as that of XNOR, and it is same as that of XOR. So this is the expression which is not representing XNOR gate. Okay, so the right option is X bar XOR Y bar. And coming to this bit, it is the dual of Boolean function. So given the Boolean function with all these operators and variables written as f power d. So the dual of a function is taken as f power d, is the same expression as that of f. So if you take the dual, it is going to generate the same expression as f with plus and dot swapped. So by swapping that, find the f is said to be the self dual if f is equal to fd. So f is said to be self dual if you find the is said to be self dual if f is equal to f power fd. So if f power fd, f is equal to f power fd, then it is going to be called as a self dual. The number of self dual functions with n Boolean variables is, so how many number of self dual functions? So this part of the expression is going to explain the definition of self dual. We have made a clear video on the complete video on the self dual functions. There we have explained that the number of self dual functions that can be formed by using n variables is 2 power n minus 1. Please watch that video. You will get the complete understanding of why we got this 2 power n minus 1, and you will also get the complete understanding of self dual functions clearly mentioned in a single video where we have made a complete understanding on self dual. Okay, hope you got the clarity on these concepts. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. And if you have any doubts regarding these concepts, post your doubts in the comment section below. Thanks for watching.